हेलो एवरीवन एंड वेरी गुड मॉर्निंग। आई होप आप लोग अच्छे हो, क्वेश्चंस कर रहे हो एंड everything is fine, I guess. So today in the class we are going to revise ray optics. I just I mean I just want to believe that you remember the basic concepts, you remember the basic formulas to be used. Yesterday also in the group I have sent for lens and for mirror thing, that short notes sort of. So there all extra things were included. I mean things that were not there in your JEE Mains syllabus. So I included all those things over there. You can go through if you have not it, and if you have your own comprehensive notes where everything is there, then it's fine. You just go through yours, the one that you are having. It's fine. And today in the class, I have selected questions, previous year questions. So that is only up to 2016 and 14. Up to that. So after the class will be over, you will be practicing recent year's question. Okay. So through these questions, we will be first revising all the concepts almost. So let's start with the very first question. ठीक है, क्योंकि देखो रे ऑप्टिक्स इज ऑल अबाउट प्रैक्टिस. मोर यू प्रैक्टिस, मोर देयर विल बी चांसेस यू विल बी सॉल्विंग द क्वेश्चन. सो इट्स मैंडेटरी दैट यू सॉल्व द क्वेश्चंस मोर नंबर ऑफ. So this is the first one. Look at it and let me know. ठीक है. Okay, I've got one answer and uh, it doesn't feel correct. You can recheck. Which formula you need to use? There is one formula called Cauchy's formula, where we have learned that refractive index of media is the function of wavelength of light entering into it. I mean, even if you're given any media, that won't have an absolute value of refractive index. Like for glass, we say it is 1.5, but we say this with respect to the white light, right? If we are using any other color of light, this refractive index will change of the glass. So refractive index is basically function of wavelength in this way. That is called Cauchy's formula. So here you need to use this formula first thing, and one very common formula you need to use, that is total internal reflection ka formula, that is sin IC is equal to 1 by mu. Done it. This is the thing. So let's talk about the question here. There is a beam of light consisting of red, green, and blue colors, each incident on a right angled prism like this. The refractive indices of the material of the prism for the above red, green, and blue are given. We have to talk about separation hoga kaise. So incident light, that is incident normally on the first surface A and B. All color will go undeviated like this, है ना? Because here it feels like there is no refraction happening. Done it. So all color will go straight like this. Done it. Now, what will happen at this surface? This surface, either refraction will occur or total internal reflection will happen. What in the case of total internal reflection? If you calculate total internal reflection, let's draw. I feel like one answer that I have got is correct. So here, if you draw this, this is the angle of incidence, right? Let's calculate IC for random wavelength of light. Okay, and for that we will take refractive index is mu. So this is your 45 degree, and this is your 90. This is 45. Again, this is 45. So if you write a Snell's law at the point O, you will write here what? Mu into sine 45, and this is equal to how much? This is equal to 1 into sine 90, because we are considering outside media is air having refractive index 1. So from here you can simply see mu is equal to how much? 1 by sine 45, that is your root 2. Okay? So if refractive index is root 2, we will get what? We will get total internal reflection. Okay? So if you see here for total internal reflection, what is the case? I should be greater than IC. That is sine I should be greater than sine IC. Okay. And sine IC here is equal to how much? It is equal to 1 by mu. So that is, I mean, if you put here, there are three this thing given. Okay. So how to compare it? Okay, just give me 1 second. So if we talk about any light, blue or red or anything, angle of incidence is same, right? So sine, so okay, let's check. So sine I should be greater than sine IC, and sine IC here हमें कितना मिला है? Sin IC is your 1 by mu. ठीक है, सो यहाँ पे आप सिंपली ये पुट कर दो, साइन आई इज ग्रेटर देन 1 बाई म्यू. इनइक्वालिटी में डालोगे तो चेक करने में आसानी होगी. ठीक है, सो साइन आई शुड बी ग्रेटर देन 1 बाई म्यू. एंड if you put it here, sin I value is how much? 1 by root 2. So 1 by root 2 is greater than 1 by mu. That is, mu should be less than root 2. So for mu less than root 2, we will be getting the condition of what? Total internal reflection. Now check, root 2 means 1.414, which for which color this is less than root 2? It is for this color. So this is the color of red. Done it. So for red light, what will happen? Total internal reflection will happen. So red light will get internally reflected. And what will happen with green and blue light? Green light के लिए ये किधर जाएगा? बाहर जाएगा. I mean, it won't come inside the triangle. So what will be the answer? Separate the red color from the green and blue color. It is correct. Separate the blue color from the red and green. No. ठीक है ना? So correct answer should be A actually. Yeah, it's A. Somebody gave me the answer B. तुम लोग समझ पा रहे हो क्या है? जैसे लेट मी डिलीट एवरीथिंग फ्रॉम हियर. सिंपल है. यहाँ से तुम्हारा इस पॉइंट पे यू जस्ट राइट. I mean, for total internal reflection, you know the condition. I should be greater than IC. So sine I should be greater than sine IC. And sine IC is equal to how much? 1 by mu. So that is equal to 1 by mu. Here we already know I is equal to 45 for all color of light. So this is 1 by root 2 is greater than 1 by mu. That is, mu is less than root 2. So for whatever value of mu less than root 2, we will get total internal reflection. So here red color will get internally reflected. Blue and green color will go out. So we are able to separate red from blue and green. That will be the answer. So correct answer is your A. Then and here Koch's formula was not in application basically. I felt like that is there, but it's not there. But in the questions ahead or somewhere you may get. So mu is a function of wavelength. You should remember this thing. Okay? Chalo. Now let's start with this question. Do it. You also, I mean, you just need to juggle with Snell's law and all. Take your time, do it like me. Okay? Take your time, you can let me know. Okay? Okay. Okay, I got one answer that is correct. Okay. Others also, let me know. Okay, let me end the poll here. So, what is the question? There is a ray of light from a denser media. So, this is denser, this is rarer. Angle of incidence I is given. It is getting refracted with angle of refraction r dash. Also, some of it is getting reflected with angle of reflection I, sorry, r. So, I must be equal to r according to law of reflection. And one more thing is given here, reflected and refracted rays make an angle of 90 degree with each other. So here r plus r dash is equal to how much? 90 degree. It is given. We have to calculate the critical angle. अगर आप critical angle की बात करो, then it is, I mean, from denser media to rarer media it is going. So there is a chance of total internal reflection. And when light travels from denser to rarer media, and we are calculating angle of uh, critical angle, then we take angle of refraction as 90 degree. And if you write here, let's say this angle is IC. So sine IC into refractive index of denser media is equal to sine 90 into refractive index of rarer media. And here one is what? Rated media, it's not given. I mean, its refractive index is not given. Let's take its refractive index to be yes, then it's correct. So sine 90 mu will be what? Refractive index of denser media with respect to rarer media. So sine IC को अगर आप लिखते हो, then you write what? It you will write as 1 by mu dr. We have to calculate this thing, right? Now let's check with things over here. कि basically मुझे 1 by mu का value निकालना है. Done because mu is not given. So if you write at point O for this given diagram, Snell's law, then you will be writing what? You will be writing sine I mu denser is equal to sine r dash mu rarer, right? So if you write here for if you go further, sine I is equal to r dash को क्या लिख सकते हैं 90 minus r लिख सकते हैं ठीक है so that will become how much r dash को अगर 90 minus r लिखते हो तो बन जाएगा cos r and this is equal to mu r by mu d. ठीक है, एंड r is equal to I, right? R is equal to I, so इसको आप क्या लिख सकते हो? I. So this will become sin I is equal to cos I by mu dA, right? So what is the value of mu dA? If you see, this is cot I, ठीक है, और अगर आप यहाँ से आंसर पुट करते हो तो साइन आई सी इज इक्वल टू हाउ मच? It is equal to 1 by mu dA, that is dr, whatever you call it. So that is equal to how much? 1 by cot I. So this will become equal to tan I. ठीक है, so IC is equal to what? Sin inverse tan I. And if you do sin inverse tan I, there is no option as such, but there is tan R wala option. I is equal to R. So this can also be equated to sin inverse tan R. So correct answer will be what? A. ठीक है, डन, चलो, A will be the correct answer. Let's do it now. चलो, again I will be launching the poll so that you can answer there also. Take your time. Sorry, I was trying to speak. I was unmuted. Sorry, muted. So I got three answers. Two fills incorrect. One fills correct. Yes. So now I will take up this question. Let's do it. Okay. So what is the question given? Question हमारा simple है. There is a concave mirror that is placed on a horizontal table with its axis directed vertically upward. So there is a table upon which there is a mirror kept. Okay, ऐसे draw करना won't be good idea because then this mirror is having so many curvatures. I mean that R is not looking constant. So mirror will look like this. ठीक है, it is initially like this. Let's say this is the pole of mirror P, and then there is object O here. This is silvered like this. since this is mirror, it will be silvered. It is like this. And initially, when object is kept at O is what? O is the center of curvature of this mirror. Then definitely, image will get formed at O itself, real and inverted, right? Now what we are doing, we are filling it with water. Now here we are keeping water. And because of keeping the water in the portion of lens that can accommodate it, what is happening? Object position is same, but focal length of the mirror will change. Why it is going to change? Because देखो, initially तुम्हारा ऐसा mirror था, and then there was object at point O. If whatever light was going here on the surface, it was getting reflected like this. ठीक है, ऐसे, sorry. It was getting reflected like this. But now what things will happen? Okay, let's see. So what will happen? Abhi, initially only reflection was happening. Now refraction will also occur such that पहले जो भी light आ रहा है यहाँ पे refract करेगा, and because of refraction it will go like this, then fall on the mirror, then get reflected, and then again refract at this surface. फिर से वो क्या करेगा, रिफ्रैक्ट करेगा, एंड इट विल गो समथिंग लाइक दैट, एंड देन बिकॉज ऑफ दैट इमेज विल गेट फॉर्म. ठीक है. सो बेसिकली यहाँ पे हो क्या रहा है, टू रिफ्रैक्शंस आर हैपनिंग एंड वन रिफ्लेक्शन इज हैपनिंग. So sort of when you form the images, diffraction happens in case of lens, reflection happens in case of mirror, and overall what thing is happening over here? Uh, just give me 1 second. I need to check with the power. चलो ठीक है, just slight confusion happened. There was no power problem thing. Sorry. So now two things are happening. Refraction is also happening, and at the same time, what is happening? Reflection is also happening. So this is containing property of both mirror and lens. It seems like, but finally the ray that is coming out is I mean mirror जब आप बनाते हो, then reflected light looks like what? It looks like this. I mean, it's going like this, then coming back on the same side. And if you talk about lens, then refracted light goes on the other side of the lens. But here, what is happening after refraction and reflection, two refraction, one reflection, light is finally coming out on the side of this thing. It means overall it is behaving like a mirror. And in this case, we define focal length of the mirror. So this is called silvering of lenses. So if you have a lens like this and you have silvered it, one side you have silvered, right? So then you can calculate focal length of this whole system. And this whole system is acting as a mirror basically. Done it? What will be its focal length? So focal length you will write like minus 1 by f net. Why minus sign I'm giving? Because this whole system is acting as a mirror. And power of mirror को हम कैसे लिखते हैं? That is minus 1 by f. Power of lens we write like 1 by f, but for mirror if you go on to write the power, you give you give negative sign. ठीक है. So इसलिए minus 1 by f net मैंने लिखा. How many times refraction will happen? How many times refraction will occur here and here? So two times. So here you will write 2 by f lens. Again, one time reflection is occurring. So minus sign again, 1 by f mirror. So this will be the formula used to calculate net focal length of the system given over here. In our case, what is the what this thing is looking like? This silvered lens is looking like what? This mirror is like this. It is like this. This is the one surface which is planar, and then this is silvered. अगर आप यहाँ पे फोकल लेंथ निकालते हो, माइनस 1 by f net will be equal to 2 by f lens minus 1 by f mirror. ठीक है. So if you go on to calculate focal length of the lens, what sort of lens is this? This is a plano-concave lens, right? So plano-concave lens का 1 by f L अगर आप करोगे, this is the first surface I am taking. So here I will write mu minus 1. Mu is given in the question, not it's the water. So let's say mu is greater than 1, obviously. Mu minus 1, and this is equal to how much? 1 by infinity minus 1 by r. Okay. So this will become how much? Minus mu minus 1 by r. Okay. And if you go on to solve it, what thing you're going to get? Minus 1 by f is equal to 2 by f length you will be writing, and f length is equal to how much? 1 by f length is this. So यहाँ से आप लिख लो 2 mu minus 1 divided by r with negative sign here, because negative we have got here. Minus 1 by mirror. Mirror का यहाँ पे focal length क्या है? r, because uh, I mean, let's if radius I'm taking, radius of this surface I'm taking as r, then what will be the focal length? Focal length will be r by 2, right? So this is 1 by r by 2. Okay. If you go on to solve it, you will be getting how much? Minus 2 mu plus 2 minus 2 by r. So this is minus 2 mu by r. ठीक है. Minus 1 by f is equal to minus 2 mu by r. So now if you solve it, 1 by f equal to 2 mu by r. So focal length is equal to how much? R by 2 mu. So r by 2 is what? Focal length of the mirror. ठीक है. And this divided by mu it is. So where is the object kept? I mean, what is the focal length here? Focal length, new focal length is r by 2 into mu. So now let's check with the thing. Where is the object kept? Object कहाँ रखा हुआ है? हमें जो new mirror मिला वो कुछ ऐसा है, and its focal length is r by 2 mu. Where is the object kept? Object is kept at center of curvature in initial case के लिए, यानी कि ये kept था 2r distance पे. डन है. अभी फोकल लेंथ हमारा कहीं इधर है, and its value is r by 2 mu. So you can clearly see here, न्यू मिरर का अगर आप सेंटर ऑफ कर्वेचर निकालोगे, तो न्यू मिरर का सेंटर ऑफ कर्वेचर कितना होगा? आई मीन r बाई 2 म्यू इंटू आर. सो ये कहीं इधर ही होगा, c से पहले ही होगा. सो दिस ऑब्जेक्ट इज बेसिकली केप्ट beyond the center of curvature of new mirror, and if object is beyond, then image will get formed where? You just have to look for that. Real and will remain at c? No. Real and located at point between c and infinity. क्योंकि हमारा ऑब्जेक्ट कहाँ है? ऑब्जेक्ट इज बियॉन्ड सी, राइट? सो इफ ऑब्जेक्ट इज बियॉन्ड सी, इमेज वोंट गेट फॉर्म्ड बिटवीन सी एंड इंफिनिटी, दैट इज बियॉन्ड सी. दिस ऑल्सो लुक्स इनकरेक्ट. वर्चुअल एंड लोकेटेड, वर्चुअल तो नहीं बनेगा बिकॉज ऑब्जेक्ट इज नॉट केप्ट बिटवीन फोकस एंड पोल्स. दिस इज रॉन्ग. रियल एंड लोकेटेड एट अ पॉइंट बिटवीन सी एंड ओ. यस, इट लुक्स करेक्ट. क्योंकि इमेज is here, so it will get formed between focus and pole wala region, right? So that is correct. Correct option will be D. So इस question का concept क्या है? Just you have to know how to calculate focal length of silvered lenses. ठीक है. In this case, initially lens was not given, mirror was given. You are pouring water in it. That will now behave like a silvered lens. So you just need to calculate the focal length of the system. System is acting like a mirror. So finally, when you are going to calculate focal length, write things like this. Why 2? Because 2 times refraction happened. I did it and then I checked it. Okay. So this is how we go around such questions. Now do this. किसी को डाउट हो, यू कैन आस्क मी. इस क्वेश्चन में तुम्हें सॉल्व नहीं करना है, ध्यान से बस क्वेश्चन को देखो. यू विल गेट द आंसर इंस्टेंटली. जस्ट बी केयरफुल व्हाइल यू आर रीडिंग द क्वेश्चन. Okay, I got two answers. One feels correct, another no. Yeah, one correct, one wrong. Look at the diagram. Just draw the diagram, okay? Sohil, yes, that will be correct. आप डायग्राम को ध्यान से देखो. Single, this is a single plate thing, right? Single slab sort of thing. And when you allow an incident light pass through the slab, what emergent light looks like, that you have to check. इमर्जेंट लाइट क्या होता है? इंसिडेंट लाइट से पैरेलल होता है, राइट? तुम लोगों ने पढ़ा है ना, अगर स्लैब से ऐसे ऐसे इंसिडेंट लाइट किया, आई हियर इट विल गेट रिफ्रैक्टेड एंड देन अगेन इट विल इमर्ज सच दैट this light, incident light, and this light, emergent light, they are parallel, laterally shifted, right? Lateral displacement hota hai, but they are parallel. So from here, whatever light will get refracted, and finally it will refract again, such that this light and this light are parallel. Similarly, here the same thing will occur, and what it will look like? Again, this light and this light are parallel. So these two lights are same as these two lights, right? You extend these two lights behind and you will get this angle. This angle will be again equal to what? Sorry, Sohel, that will be alpha. You said zero na? Zero nahi, alpha hoga na? What should be the angle of, what was the question? Divergence angle of emergent wave. So it should be alpha. Okay, answer D लिखा है मैंने.
अल्फा/2 होना चाहिए ना, एंगल हाफ हो जाएगा.
कैसे?
हम जो इंसिडेंस एंगल होगा वो इस में.
जैसे यहाँ से आप देखो, इनिशियली क्या है, दो इंसिडेंट रेज थे, ठीक है, ऐसा, ये लाइट था, ये लाइट था. सो इन दोनों के बीच का एंगल क्या है? अल्फा. सो दीज आर टू इंसिडेंट रेज, एंड देन वी आर गेटिंग टू इमर्जेंट रेज, राइट? And this ray is parallel to this is parallel to this. So angle between these two lines is alpha. Angle between these two lines should also be what?
ओके मैम, दो टिकट मैम, मुझे लगा कि एक के लिए पूछा जा रहा है.
नहीं नहीं, हाँ, अल्फा
तो
होगा. हाँ,
मुझे
एक के लिए निकालोगे तो यू विल गेट, यू कैन गेट लाइक दैट. या, बट व्हाई आई हैव रिटन डी, आई नीड टू चेक विद दैट. इट शुड बी बी. ठीक है, आई विल चेक एन अपडेट. इन द मीन टाइम लेट्स डू अनदर क्वेश्चन. चलो यहाँ पे फोकस करो. आई विल चेक विद दैट क्वेश्चन. Yes, that will be B only. Chalo. Let me know here. चलो साथ में करते हैं, तुम लोग अब तक बहुत कुछ सोचे होगे, so that will be helpful now. So what is the question? We need to read it carefully. There is an observer can see through a pinhole at the top end of a thin rod of height h. So there is a thin rod here of height h, and there is a hole here, pinhole, very small hole is there. And through this small hole, the person is able to see something. There is a rod of height h kept, and it is able to just see the uh, top edge of the rod. ठीक है, ठीक है. The beaker height is 3h and its radius is h. डन है. कहां तक देख पा रहा है, समझ रहे हो ना, यहां तक ही देख पा रहा है. यानी कि यहां से अगर स्ट्रेट रे जाती है तो वो इस होल को क्रॉस कर सकता है, एंड दस इट विल रीच द आई एंड द पर्सन विल बी एबल टू सी. ठीक है. सो दिस इज गोइंग टू हैपन. अब देखो, यहां से अगर रे जाता है यहां कहीं से, तो इट वोंट बी एबल टू रीच द पिन होल, एंड दैट इज व्हाई द पर्सन इज नॉट एबल टू सी एनीथिंग टू द बॉटम ऑफ दिस टॉप पॉइंट, दैट इज टॉप ऑफ द रॉड. ठीक है. सो उससे नीचे वो कुछ देख नहीं पा रहा. नाउ वी वॉन्ट इट टू see the whole of rod. Yani ki to seeing the whole of rod, condition should be what? It is able to see the bottom part of the rod also. So let's say it is able to see this part also. And for this, what we are doing? We are adding water. So the beaker height is 3h and its radius is h. When the beaker is filled with a liquid up to height 2h, so up to height 2h, we are filling it with water. ठीक है. सो 2h हाइट ज्योमेट्रिकली करेक्ट दिखने के लिए मुझे यहाँ ना बनाकर थोड़ा और नीचे बनाना चाहिए ना. तो लेट्स से हियर. डन है. नाउ व्हाट इज हैपनिंग? when beaker is filled up to a height 2h, he can see the lower end of the rod. Then the refractive index of the liquid is what? So lower end से अगर आप यहाँ से लाइट को ले जाओ, and let's say it is incident here. Done it. And since it is able to see this point, it means it will refract, and it will refract in such a way that this light is able to reach this point. कहने का मतलब ये है, अगर मैं इसको और क्लीन बनाऊं तो यहाँ पे जो भी लाइट बॉटम से आ रहा है, देखो स्ट्रेट बन नहीं पा रहा, यहाँ पे जो भी लाइट बॉटम से आ रहा है, इट इज लाइक दिस. तो अगर लिक्विड नहीं होता, इट वुड हैव गॉन दिस वे, बट बिकॉज ऑफ लिक्विड इट इज गेटिंग रिफ्रैक्टेड. लिक्विड से एयर में जा रहा है, सो इट विल रिफ्रैक्ट अवे फ्रॉम द नॉर्मल. ठीक है. एंड रिफ्रैक्टेड इन सच अ वे दैट इट इज ज्वाइनिंग दिस लाइन. सो रिफ्रैक्टेड लाइट इज अलोंग द इनिशियल इंसिडेंट लाइट जो ड्रॉ करके क्वेश्चन में दिया है. देन ओनली दिस पर्सन विल बी एबल टू सी. Now, geometrically, we have to go around it. We just need to calculate what? Uh, the refractive index of the liquid. How we can do this? Let's say यहाँ पे मैंने एक normal बनाया, ठीक है? And let's say this point I'm taking at the middle. So this is at this point. क्योंकि geometrically we need to calculate everything. So let's say this is h by 2. Done it? And from the bottom,
मैम
one
एच
light
होगा ना,
is, sorry.
एच होगी ना
Yes.
शायद वो.
Yeah, H. Sorry. Yes, it will be H. Thank you. So this is your H. Now what will happen? हमने एक incident light लिया bottom से. Let's say this is angle of incident light, and this is going out like this. This light is same as this one. ठीक है? Then this person is able to see it. अब आप यहाँ पे आ जाओ ध्यान से. This light initially was here at the height H. है ना, कुछ ऐसा था. अब हमें निकालना क्या है? We have to calculate refractive index. How you will do this? If somehow you know what is this angle, we can go around this. And do we know this angle? Geometry
यस
से check.
मैम.
हाँ, कितना दिख रहा है बताओ.
मैम tan इनवर्स 1/2.
How much? Sorry, your
tan
voice
इनवर्स
is
1/2.
1 by root 2.
tan इनवर्स 1/2.
10 inverse 1 by 2. Okay. But how you got it? Geometrically clearly नहीं दिख
ज्योमेट्री
रहा
से.
है.
मैम 2h है ना हाइट वाटर की, तो और वो h है, तो बेस की हाइट 2h और परपेंडिकुलर h, तो tan इनवर्स 1/2.
ठीक है, ठीक है, लेट्स चेक हियर ऑल्सो। वैसे मुझे एंगल क्लियरली 45 दिख रहा है। कैसे? जैसे यहां से देखो, ये 2h हाइट तक हमने वाटर रखा था। ठीक है, सो दिस इज 2h हाइट, दिस इज h ऑलरेडी, सो दिस इज h, राइट? This is H and this is also H. So if you consider this triangle, this side and this side are equal. This is 90 degree. So this has to be 45. This has to be 45. And if this is 45, this has to be 45. Okay? From the geometry, you can see it. This has to be 45. So यहाँ पे अगर आप O point पे Snell's law लगाते हो, you will simply write mu sin I is equal to refractive index of air. Nothing is given, so we will take 1. 1 into sine 45. This is this. Now somehow we need to calculate the value of sine I. We can calculate sine I, right? This is h. This is 2h. So this will become how much? Root 5h. So sine I is equal to how much? That is equal to h by root under 5h. So 1 by root under 5. So keep here mu and keep here 1 by root under 5. And this is equal to 1 by root 2. So mu is equal to how much? It is 5 by 2. This is going to be the answer. Correct है? So correct answer will be B. देखो सारी चीजें ज्योमेट्री से करनी थी हमें. First we needed to understand the question conceptually, then we needed to apply the things. That is geometry. So correct answer will be what? D. Done? चलो, if no doubt, then we can move ahead with next question. You can relate this question with the first one we did, okay? And then you can easily do. Okay, I got two answers and it feels correct. Just check. Sohel, yes, it looks correct. What will be there in emergent range? First of all, for anything to be in emergent range, for that color of light, this I should be greater than IC, and so sine I should be greater than sine IC. And you already know sine IC is equal to how much? 1 by mu. Done it. And you know 1 by mu is, just now I said mu is directly proportional to 1 by lambda square. So 1 by mu is directly proportional to lambda square. So this I can write as k lambda square. Okay. So if I write here, sine I is greater than sine IC, and sine IC has to be what? Uh, देखो सही से कंपेयर करो. हाउ वी कुड गो अराउंड कंपेयरिंग. सो फॉर ग्रीन लाइट व्हाट इज हैपनिंग, दिस इज द क्रिटिकल एंगल. डन है. So if you put here sin IC for green light, that will be equal to k lambda square. That is, this is for the green light. ठीक है. And for any greater wavelength आप निकाल लो, suppose कर लो sin IC I am going to calculate for the red light, then this should be equal to k lambda r का square. ठीक है. So for red light, this value is greater, done है, and hence angle should be greater, done है. यानी कि for this particular angle of incidence, if this is the critical angle for green light, then this angle is smaller than the critical angle of red light, and hence of any wavelength which is greater than that of green, उसके लिए ये angle I is what, less than critical angle. For which wavelength? For wavelength greater than wavelengths of green light. ठीक है. So wavelength greater than green light will be what? It will be yellow, it will be orange, it will be red. So these lights won't suffer internal reflection, so they will come out, and hence they will be in the emergent range. And in reflected ray, which lights you're going to get? Lights of shorter wavelength, shorter than that of green. So that will be your violet, indigo, and blue. So here we were asked about emerging ray. So that option should be it. Yes, this is it. So this Koch's formula is actually important. This one you should remember. ठीक है. सो ऐसे भी याद कर लो, क्रिटिकल एंगल सबसे ज्यादा किसके लिए होगा? इट विल बी ग्रेटेस्ट फॉर द रेड लाइट. So if red light is suffering total internal reflection, all light will go, all light will totally internally reflect. Simple. And if this is critical angle for violet light, then all other uh, longer wavelengths will simply go out in the emergent range. ठीक है. तो शॉर्ट में इसको याद रखो. Yeah, now let's do this question. Yeah, I got one answer. It is correct. Okay, let's discuss that sort of question. And let me tell you, there are some 3 or 4 questions of this sort in HP Verma. Questions are really good over there. In some cases, bottom is also silvered and all. So you must be practicing those 3 questions or 4 questions given in the HP Verma in ray optics chapter. So please open it. That will make things more clearer. Though their velocity thing is not asked that much, only image position for particular position of object given. But that's a very good question in terms of uh, getting to know the concepts. So you should try all those questions. चलो इसके concept को देखते हैं सबसे पहले तो. This is coming from real height and apparent height thing. So how you write the formula? First, I will go with that. Suppose there is here one coin, and then there is observer here. First, you should mark where is the observer and where is the object. So this is the observer and this is the object. Why this became object? Because this person is trying to see the coin. So this became object. Now, what is the real height? So real height is this, or real depth here. So real depth of the coin is this. So H, where this person will find the coin. So let's say from here light will go and it will bend like this. So somewhere here, let's say somewhere here. So this is called the apparent height. ठीक है. तो फॉर्मूला हम कैसे लिखते हैं? फॉर्मूला लिखने का सिंपल तरीका है, पहले रियल हाइट को आप लिख लो, एच रियल बाई एच apparent is equal to what? Try to see light is traveling from where to where. Light will always travel from object to the observer. So light is traveling from here to here, right? Let's say here refractive index of water is this and refractive index of air is this. So here you will write mu W by mu A. Simply on the left hand side of the formula, write H real by H apparent. And this side, how you will write the refractive index? See, light is traveling from where to where. So, where is the incident light? In water. So here mu W. Where is the refracted light? In air. And hence here mu A. जैसे सिल्वर के केस में हमारे क्वेश्चन में जो दिया है, हमारे क्वेश्चन में देर इज अ फिश हियर. So observer यहाँ हो गया, है ना? And this fish is noticing what? There is an object falling down. So it is noticing this object. And this formula is only true when we try to see along the normal. So in the question also, that fish is seeing along the normal. So this is the object, this is the, sorry, this is the observer, right? This is trying to see the object falling down. So this is what here? Observer. And this is what? Object. Light travels from where to where? From object to the observer. क्योंकि जिसको देखना है उसकी आंखों में light आनी चाहिए. So light will travel like this. If you will write the formula, H real by H apparent, in this case will become refractive index of air by refractive index of water. Why opposite? क्योंकि here light, incident light is, light is coming from where? Light is coming from the object. Just locate the media in which object is there. So that is your mu A. अगर यहाँ से ऐसे लेते हो तो light, incident light is here and refracted light will be in the water. So mu A by mu W. Now what is the concept of velocity? So अगर हमें displacement का relation पता है, how we calculate velocity? Simply by differentiating with respect to time. So H real is equal to H apparent, mu A by mu W. Now differentiate both sides with respect to time. This will become V real and this will become V apparent and this is equal to mu A by mu W in this case, right? So now coming back to our question, there is a ball drop from a height of 20 meters. So we are dropping a ball. Here, dropping means initial speed is 0. And from what height we are dropping it? We are dropping it from a height of 20 meters. The refractive index of water is given 4 by 3. A fish inside the lake in the line of fall of the ball is looking at the ball. That is, normally it is looking at an instant when the ball is at 12.8 meters. So when the ball is at this height, that is 12.8 meter above the water surface, the fish sees the speed of ball as what? ठीक है. तो सबसे पहले अगर आप यहाँ पे लिखोगे V real by V apparent. Formula कैसे लिखोगे? So who is the object here and who is the observer? Object is the ball. So object is in which media? In the air. And where is the observer? Observer is in water. So here there is observer. Light travels from where to where? Object to observer. So यहाँ पे mu air by mu water आप लिखोगे. Now if you know V real, you can calculate V apparent, and V real you can simply calculate by using V square equal to U square plus 2A is, because U square is 0, 2 into G ka value. Displacement is in the downward direction, acceleration is in the downward direction. I'm taking downward direction as the positive. So 2 into displacement, how much it is getting displaced? 20 minus 12.8. If you're going to do this, kitna aayega? Yes, 7.2 meter. Okay. So this you will write as 7.2. So V is equal to how much? 2 into 72. So this is equal to 36 into 4. So this is equal to 6 into 2, that is 12. So real velocity is how much? 12. Real velocity आप लिख लो 12. V apparent, and this is equal to mu air 1 है, mu W is how much? 4/3. So 3 से ये 4 times में चला जाएगा. V apparent is how much? 16 meter per second. So this is how you can solve question simply. ठीक है. इसी तरह से हम पोजीशन भी निकाल सकते हैं, कितने पोजीशन पे कितने टाइम पे किसको दिखेगा बॉल. देन चलो, नाउ लेट्स डू दिस क्वेश्चन. अगेन दिस इज फ्रॉम द सिल्वरिंग ऑफ लेंसेज. डू दिस एंड लेट मी. Okay, I got one answer. Um, let's see that is correct or not. It feels correct. Yeah, very good. You simply calculate the focal length of the system. Then you calculate image position by using mirror formula. Because मैंने बोला है when you are silvering the lenses, system is becoming a mirror. So this is a mirror. Done it? And in mirror, if object position is given, image position आप कैसे निकालोगे? 1/v plus 1/u equal to 1/f. So the function here is to calculate f, right? U is already given, I guess. Yes. U is given as 20 centimeter. ठीक है. और if आप कैसे निकालोगे? If you want to calculate here focal length, मैंने बताया था focal length of mirror, that is minus 1/f, that is focal length of the system, is equal to 2/f lens minus 1/f mirror. ठीक है. Which mirror? The the part of lens which is acting as a mirror. उस मिरर का फोकल लेंथ यहाँ पे लिखना है. ठीक है. सो यहाँ से अगर आप देखो तो वी हैव लेंस. व्हाट सॉर्ट ऑफ लेंस वी हैव अ प्लेनो कनकेव लेंस. एंड व्हाट सॉर्ट ऑफ मिरर वी आर हैविंग? वी हैव दिस सॉर्ट ऑफ मिरर. So this system consists of plano convex lens and plane mirror, right? सिस्टम का फोकल लेंथ ऐसे निकालेंगे. वाई 2 आई डिड बिकॉज इफ हियर इज द ऑब्जेक्ट, रिफ्रैक्शन यहाँ पे होगा, यहाँ रिफ्लेक्शन, अगेन रिफ्रैक्शन. Refraction 2 times, and refraction is the property of lens. So 2 by f length I have written, and since only reflection happening once, so 1 by f mirror y minus, because focal length mirror का हम क्या लिखते हैं, पावर मिरर का क्या लिखते हैं, -1 by f. इसलिए सिस्टम का भी मैंने -1 by f लिखा है, क्योंकि सिस्टम इज एक्टिंग एज ए मिरर. अब आप लिखो 1 by f लेंथ निकाल लो. इफ यू कैलकुलेट 1 by f लेंथ, यूज द लेंथ मेकर्स फॉर्मूला, म्यू -1. तो म्यू इज गिवन. अच्छा, यहाँ तो निकालना भी नहीं है, तुम्हें फोकल लेंथ ही दिया हुआ, तब तो चाप नहीं है, डायरेक्टली लिख डालो. क्या है, प्लेनो कन्वेक्स लेंस ऑफ फोकल लेंथ 15 सेंटीमीटर. सो हियर राइट माइनस, सॉरी +2 था. एंड फोकल लेंथ ऑफ प्लेनो कन्वेक्स लेंस क्या होता है, पॉजिटिव होता है. इफ यू रिमेम्बर दिस थिंग विल बी व्हाट, पॉजिटिव. साइन कन्वेंशन के साथ लिखना लेंस का भी जब लिख रहे होगे. सो बी केयरफुल हियर. 2/15 I will write, and this is -1 by infinity, because focal length of plane mirror is what, infinity. Radius of curvature of plane mirror is what, infinity. So -1 by f, 1 by f is equal to how much, -2/15. Now let's write it here. 1 by v plus 1 by u कितना लिखोगे, point object is placed at a distance of 20 centimeter. तो साइन कन्वेंशन के साथ यूज करोगे, ऑब्जेक्ट डिस्टेंस विल बिकम नेगेटिव. -20 is equal to -2/15. So if you do 1 by v, this is 1 by 20 -2/15. Let's make the denominator same. That is the favorite thing I do. So I will do it like this. This is -5/60. So that is -1/12. So minus sign indicates that obviously system is acting as a mirror. Image will get formed on the side of object itself. If है ना, हमेशा ऐसे ही बनेगा. तो 12 सेंटीमीटर टू द लेफ्ट ऑफ द सिस्टम, दिस साइड ओनली इमेज विल गेट फॉर्म. ठीक है. तो यहाँ से दो ऑप्शन तो डायरेक्टली कट हो जाता, वो था ये और वो था तुम्हारा ये, क्योंकि बी और डी में इमेज कहाँ बन रहा है, राइट साइड ऑफ द सिस्टम, विच इज ओनली पॉसिबल इफ सिस्टम इज एक्टिंग एज व्हाट, या मिरर के केस में भी पॉसिबल है. मिरर में वर्चुअल इमेजेस, अगर तुम कन्वेक्स, कनकेव कौन सी मिरर होता है वो ऑपोजिट वाला, जो मिरर ऐसा दिखता है, इसमें इमेज, देखो मैं बहुत जल्दी चीजें कंफ्यूज करती हूँ. तो आई डोंट, आई मीन यू मस्ट बी अवेयर ऑफ कि कैसे इमेज बनता है. ओके, वर्चुअल इमेज ऑल्सो गेट्स फॉर्म्ड ऑन द सेम साइड ऑफ ऑब्जेक्ट, राइट. कोई मुझे आंसर करेगा प्लीज.
दूसरी साइड बनती है मैम.
सॉरी, वॉइस ऑडिबल नहीं है यार. आई जस्ट वॉन्टेड टू से कि ये दो ऑप्शन डायरेक्टली कट होगा या नहीं होगा. मैं वहां पे कंफ्यूज कर रही हूँ, क्योंकि इमेज पोजीशन मुझे क्लियरली दिख नहीं रहा. ठीक है, ये तुम लोगों को याद ही होगा, तुम लोग देख लेंगे. आई डोंट वांट टू कंफ्यूज एनीबॉडी. चलो, कॉन्सेप्चुअली दिस शुड बी क्लियर, है ना. डू इट नाउ. आई एम एंडिंग द पोल and starting the new one. Okay, so let's do it together. So question क्या है? We are having a lens like this. It is looking like a convex lens, but half of the thing has refractive index 1.5 and another half has a refractive index of so here I feel like B is correct. Yes. ठीक है. So यहाँ से अगर आप सिस्टम को देखो तो हमारे पास एक लेंस ऐसा है, ऐसा जिसका रिफ्रैक्टिव इंडेक्स क्या है 1.5 and then another lens is this one whose refractive index is how much 1.2 and we have combined them together to get this system. ठीक है. So basically this is a question of combination of two thin lenses and whenever we are given combination of lenses, thin lenses, net focal length is equal to 1 by f1 plus 1 by f2. So our task is to calculate 1 by f1 and 1 by f2. ठीक है. So let's take the incident light. Incident light मैंने ऐसे लिया. Why I'm taking incident light? So that I can use properly sign convention. So let's calculate now 1 by f1. 1 by f1 आप कैसे लिखोगे? Mu minus 1. That is 1.5 minus 1 divided by radius of curvature of this surface. So इस surface का center किधर होगा? कहीं इधर होगा. So इस surface का center will be somewhere here. So you are measuring distance in this direction, that is in the direction of incident light. So I will take 1 by r. And this surface has a radius of curvature equal to infinity. So this is this. And this will become equal to how much? 0.5 by r. That is 1 by 2r. If I am not correct. Calculation देखते जाना, ठीक है? 1 by f2 will be equal to how much? 1.2 minus 1. Now let's focus on this thing. Incident light is incident here and then here. ठीक है. So ऐसे लाइट गया and it is falling on this thing like this. So R1 कौन सा surface हुआ second lens के लिए? Incident light is first incident on which one? This one. So this is R1. So 1 by infinity minus. This is what? This is it. It will have center somewhere. So this is the radius of curvature. We measure from the pole. इधर से इधर measure करोगे. So we are measuring opposite to the direction of light. It will become minus R. Both have same radius of curvature. Yes. So minus 1 by r. So 1 by f2 is equal to how much? 0.2 by r, that is equal to 1 by 5r. If you calculate the total focal length, that will be equal to 1 by 2r plus 1 by 5r. So this is equal to 7 by 10r. ठीक है. एंड r इज इक्वल टू हाउ मच 14 सेंटीमीटर. अगर यहाँ पे आप 14 रखते हो तो दिस विल बिकम 1 by 20. दैट इज f इज इक्वल टू 20 सेंटीमीटर. नाउ व्हाट इज द डिस्टेंस गिवन? क्या निकालना क्या है? For an object distance of 40 centimeter, image distance will be what? We don't need to put in the formula because focal length is 20. Then center of curvature will be at a distance of 40 centimeter. Object is kept at the center of curvature. Image will also get formed at the center of curvature on the other side. So this is 40 centimeter. Because net focal length we are getting plus 20. It means this whole combination is acting as a conversing lens, that is convex lens. ठीक है. So for convex lens, if object is kept at center of curvature, image will get formed on the other side of the lens at center of curvature, and that is why answer will be what? 40 centimeter. ठीक है. So that is the thing. Now let's do this question. Yes, let's do it. Just try using all the formulas that you know, I mean, concerning this question. See, in question, you don't need to use so many of things. So it should get done by this time. But if not, then let's discuss because maybe you're getting confused somewhere. So image of an object formed by a plano-convex lens at a distance of 8 meter behind the lens is real and is one third the size of object. So one third the size of object means magnification in one third, and for lens magnification is b by u. So I've written b by u equal to 1 by 3. So from here we are getting u equal to 3v. Image distance is already given. Image of an object is formed 8 meter behind the lens. 8 meter behind the lens का मतलब सोहेल, yeah, it feels correct. So u का वैल्यू क्या हो जाएगा 24. ठीक है. Now you have to calculate the radius of the curved surface of the lens. So here we know u 8 meter, we know v 24 meter, and if we use the lens formula, that is 1 by v minus 1 by u, we will be calculating 1 by f. And if we know focal length, we can calculate radius of curvature by using lens maker's formula. So let's put in the values here. 1 by 8 sign convention plus I am using because image is getting formed here for object kept somewhere here, right? Object will be in front of the lens and here image is behind the lens. So this minus 1 by minus 24 and this is equal to 1 by f. If you calculate 1 by f, then this is equal to how much? This is 3 by 24 plus 1 by 24. So this is equal to 4 by 24. So focal length is how much? 6. 1 by f is how much? 1 by 6. Now let's use the lens maker's formula. So when you will use lens maker's formula, you will write 1 by f equal to mu minus 1 by r minus 1 by infinity because incident light I'm taking here. So this is this. Now यहाँ पे एक ही चीज है म्यू को तुम्हें लिखना है सो द वेवलेंथ ऑफ लाइट इनसाइड द लेंस इज 2/3 टाइम्स द वेवलेंथ इन फ्री स्पेस फोकल लेंथ सॉरी रिफ्रैक्टिव इंडेक्स कैसे निकालते हो स्पीड ऑफ लाइट इन वैक्यूम डिवाइडेड बाय स्पीड ऑफ लाइट इन मीडिया और तुम्हें पता है ड्यूरिंग रिफ्रैक्शन व्हेन मीडिया इज चेंजिंग व्हाट हैपेंस वेलोसिटी बाय वेवलेंथ का रेशियो कांस्टेंट होता है दैट इज फ्रीक्वेंसी डजंट चेंज वेलोसिटी चेंज वेवलेंथ चेंज सच दैट फ्रीक्वेंसी इज कांस्टेंट राइट सो यहाँ पे सी को आप क्या लिख सकते हो सी को लिख सकते हो वेवलेंथ इन वैक्यूम in air into frequency in air divided by wavelength in media frequency in media that will same as frequency in vacuum so this is same lambda v by lambda m and lambda m is how much that is 2 by 3 times so 2 by 3 times lambda v so this is giving you 1.5 right so यहाँ put कर दो 1.5 minus 1 by r and this is 1 by f 1 by f is how much 1 by 6 so what will be the values बताओ this is 1 by 2r this is this r is equal to 3 meter ठीक है सोहेल so तुम्हारा f 6 आया था you needed to use the lens maker formula to calculate r so the correct answer should be what it should be c yes that is your 3 meter so nothing much to do here right let's do this question this is actually this is a question coming from simply derivation so do it and let me know what options you're getting I really want you to try this try it let me know Okay, no answers so far. So should we discuss it? I mean, let's do it together. ठीक है. So question क्या कह रहा है देखो. There is a transparent thin film of uniform thickness and refractive index N1 1.4, and this is coated on the convex spherical surface of radius r at one end of a long solid glass cylinder of refractive index N2. Okay, so there is a thin film sort of thing, and this side there is a refractive index of 1.5, and this side there is air. Now what is happening? Rays of light parallel to the axis of cylinder. So rays of light parallel to the axis of cylinder. So if rays are parallel, incident rays are parallel, it means they are coming from infinity. It means incident light comes from where? From the object. So object distance is what? Infinity. That we can say for sure. Done it? And what is happening? This is uh, traveling through the film from air to glass, gets focused at a distance f1 from the film. फिल्म से ये कितने डिस्टेंस पे फोकस हो रहा है f1 डिस्टेंस पे. ठीक है. एंड while range of light traversing from glass to air gets focused at a distance f2, and similarly if you are allowing parallel rays of light fall from this side, then it is getting focused at a distance f2. ठीक है. अब तुम खुद सोचो, if this system is acting as certain, I mean it's acting as a curved surface, right, which is separating two medias, and whenever there is a parallel light coming from somewhere, when it will converge to a point that we will call as focus, right? So in the first case, it is converging at f1. In second case, it is converging on f2, and we have to talk about f1 and f2 ka value. Let's calculate it. But this question is coming from where? Refraction through curved surfaces. ठीक है. So चलो पहले first case को हम discuss करते हैं. What is the first case here? In first case, rays of light is coming from this side and falling on the film, from air to film. ठीक है. So let's use the formula. Refraction through curved surface का formula है क्या? So that is n2 by v minus n1 by u equal to n2 minus n1 by r. This is the general formula, right? When light is falling from air on the film, what is the case? It is like this. Here there is air, here there is film of refractive index n1. So for refraction through this surface, this is a curved surface separating two media n1 and air. So for this thing, if you apply this formula, what you will be writing? Let's write it. ठीक है. So यहाँ पे ये फॉर्मूला कैसे कैसे होता है? n2 by v का मतलब v is the image distance, so n2 is basically the refractive index of media where refracted light is going. ठीक है. And n1 is the refractive index of media in which incident light is there, and n2 minus n1 you can understand, you can understand, right? So in first case, when light is coming from air and falling on this thing, n2 is equal to what? n2 किसके बराबर है यहाँ पे? अगर ध्यान से एक काम करती हूँ, फॉर्मूला में म्यू टू म्यू वन लिखती हूँ क्योंकि तुम लोग फिर कंफ्यूज करो, because we have to write the general form. So what I have done is mu2 is the refractive index of media in which light has refracted. Mu1 media ka refraction where incident light is there. So in this case, if we put in the formula, incident light is in media air, refracted light is in media n1. So here mu2 will become n1, and the image is getting formed where? After two refraction, it is getting formed at f1. Always remember, because यहाँ से refraction होगा first surface से, then again there is this thin film. So finally, इससे जब refract होकर आएगा ना, then it will end at f1. So final image distance is f1, not the intermediate one. So this is the intermediate image that we will write here. Let's say that is v itself. So हमने v को v रहने दिया, minus mu1, that is air. 1 लिखती हूँ मैं यहाँ पे, u infinity लिखूंगी, and this is equal to mu2 minus mu1, that is this minus this. So n1 minus 1 by r. Now what will happen? इसको और मैं थोड़ा exaggerate करके दिखाती हूँ. There is another surface here. So यहाँ से light refract हुआ, again यहाँ से refraction होगा, और जब यहाँ से refraction होगा second surface से, then whatever is the image by first surface will act as an object for the second surface. For second surface, I mean ऑब्जेक्ट विल बी व्हाट वी। ठीक है, सो चलो अब सेकंड सरफेस के लिए हम यूज करते हैं। सो सेकंड सरफेस के लिए इंसिडेंट लाइट कहाँ है, अगर आप देखो तो N1 मीडिया में है, एंड रिफ्रैक्टेड लाइट विल गो वेयर, इन N2। ठीक है, so let's use here N2 by F1 because finally it is getting converged, it will get converged at F1, so N2 by F1 minus what you are going to write, minus you will be writing N1 by V। ठीक है, why N1 I have written, because this is the media where incident light is, and V is the object distance for the second surface। Again, sign convention for intermediate image I am not keeping, because from here to here it will get cancelled, so let's keep things simple। यहाँ पे अगर आप अब सॉल्व करोगे तो N2 माइनस N1 बाई आर, वी आर गेटिंग टू इक्वेशंस, इक्वेशन 1, इक्वेशन 2। अगर आप इन दो इक्वेशंस को ऐड करोगे ना, व्हाट यू आर गेटिंग, add this two, this will get cancelled, so we are getting something like this, N2 by F1 minus 1 by infinity, and this is equal to, see here, N1 by R is here, and here minus N1 by R is there, that will get cancelled, and we will get N2 minus 1 by R। अगर आप क्लोजली देखो ना, तो इट सिम्स लाइक कि हमने सिंगल फॉर्मूला यूज किया है। अगर आप लास्ट रिजल्ट को देखो, इट विल सीम लाइक वी आर यूजिंग सिंगल फॉर्मूला फॉर one media having air, another media having refractive index N2, object was parallel to the parallel, so coming from the infinity, u was infinity, and it finally got converged to a point at a distance f1। so overall जब हमने यूज किया ना, we realized that this thin film is playing no role, इसका कोई रोल ही नहीं है। डन है, सो सिंपल, दो इक्वेशन हमने लिखा क्योंकि हम रैंडमली ऐसे rule out नहीं कर सकते, we need to write and then check, so this thin film is not at all playing any role, and now you calculate this f1। अगर आप f1 यहाँ से निकालते हो, what you will be getting, बताओ, N2 is how much, is it given 1.5 by f1, and this is equal to N2 minus 1, that is 1 by 2r, so f1 is equal to 1.5 into 2r, that is 3r। ठीक है, when we need to calculate f2, f2 के लिए एक काम करो, अब हमें पता चल गया है कि फिल्म इज नॉट प्लेइंग एनी रोल, यानी कि दिस थिन फिल्म हैविंग रिफ्रैक्टिव इंडेक्स ऑफ मीडिया N1 इज नॉट एट ऑल प्लेइंग एनी रोल। सो दूसरे साइड के लिए जब आप लिखोगे तो सिंपली राइट इट फॉर मीडिया N2 एंड एयर। सो इफ यू गो ऑन टू राइट दिस, image refracted light is in air, so 1 by f2 minus incident light is in N2, N2 by U, that is infinity, and that is equal to 1 minus N2 by what R I should get, है ना, and 1 by F2 is equal to how much, 1 minus N2 minus 1 by 2R। ठीक है, so F2 is equal to how much, it is equal to 2R। so this answer, so two answers are correct, option A and option C, these two are correct। ठीक है, सो वी रूल्ड आउट द लास्ट थिंग कि जो तुम्हारा सीट है उसका कोई यूज ही नहीं दिख रहा है ना, बट स्टिल इट्स इजी, क्योंकि हमें जब भी तुमने जैसे देखो ये सारे क्वेश्चंस आ कहाँ से रहे, दिस ऑल क्वेश्चंस आर कमिंग फ्रॉम द डेरिवेशन। इफ यू हैव डन डेरिवेशन फॉर द कैलकुलेशन ऑफ 1 by v minus 1 by u equal to 1 by f length, there also we have dealt with two surfaces। एक बार यहाँ से रिफ्रैक्ट हुआ, फिर इस पे फॉल किया, एंड देन वी हैव डन ऑल द कैलकुलेशंस। डन है, सो बेसिकली दिस क्वेश्चन इज कमिंग फ्रॉम देयर इटसेल्फ, नथिंग मोर। डन है, so up to this we did, only one question was left that you will do, so this is of 2016, again question is not that difficult I would say, so you just need to read the question carefully, apply things step by step properly, you will be getting the answer। तो तुम्हारा टास्क क्या है ना, तुम लोग 2017 से लेकर 2024 तक का whatever questions are there, everyone must be having question bank, so just pick up questions from the ray optics, क्योंकि wave optics we will be doing separately, so pick up questions from ray optics, do all the questions, that will also make you revise all the formulas and also all the concepts, and also that will add to your wisdom that how to do questions from the ray optics, so it's very very mandatory that you solve all the questions from PYQs, so तुम लोग कर लेना। 2016 से इनफैक्ट स्टार्ट करना, यू वॉन्ट बी गेटिंग मोर नंबर ऑफ क्वेश्चन। एक बार बैठकर 2 घंटा दे देना, बस 2 आवर्स, सिट फॉर 2 आवर्स, ट्राई डूइंग। ठीक है। किसी को कोई डाउट है, कोई प्रॉब्लम है, एनीथिंग यू वांट टू डिस्कस, यू कैन लेट मी नो नाउ। एनी हेल्प यू रिक्वायर, एनीथिंग? यस।
मैम साइन कन्वेंशन इन स्फेरिकल सरफेसेस लाइक कैसे हो, वो बार बार कंफ्यूजन हो जाता है।
लेंस के लिए?
मैम स्फेरिकल सरफेसेस के लिए, सबके लिए लाइक।
अच्छा, सबके लिए। चलो ठीक है, मैं तुम्हें बताती हूँ कैसे होगा। वरुण, पीवाईक्यूज एक बार कर लो। करने से क्या होता है ना, फर्स्ट थिंग यू गेट कॉन्फिडेंस कि प्रीवियस ईयर के क्वेश्चंस हो रहे हैं, तो दैट विल एनहांस योर कॉन्फिडेंस। कॉन्फिडेंस का एनहांस होना भी बहुत जरूरी है। एंड सेकंड थिंग, वैसे ही क्वेश्चंस आएंगे ना, आई मीन उसके अराउंड ही क्वेश्चंस रोटेट करते हैं। सो आई फील लाइक यू शुड डू चैप्टर वाइज। Problem in revising, then how you're revising? You are selecting questions from where? You must be doing questions, right? So which questions you are doing? चैप्टर वाइज? अच्छा, पीवाईक्यूज कर रहे हो बट एग्रीगेट वे में कर रहे हो। चैप्टर वाइज, अगर तुम चैप्टर वाइज रिवाइज कर रहे हो तो तुम्हारे क्वेश्चन का तुम्हारा मतलब ये है कि एक चैप्टर का करूंगा तो बहुत सारे चैप्टर्स रह जाएंगे। इट्स फाइन, यू कैन डू एग्रीगेट ऑल्सो, दैट्स गुड। आई फील लाइक दैट्स मोर गुड अटेम्प्ट, क्योंकि अगर तुम 3 चैप्टर लेकर बैठे हो तो इट्स मोर गुड यू आर रिवाइजिंग 3 चैप्टर्स, इट्स फाइन। मैंने बस इसलिए बोला ये सारे क्वेश्चंस को रिवाइज करने के लिए, विच इज नॉट पॉसिबल फॉर यू, इट्स फाइन, but at least select some 7 or 8 questions and try doing। ठीक है, अच्छे अच्छे क्वेश्चन 7-8 सेलेक्ट करना एंड ट्राई डू। हर्षिता, कर्व सरफेस में देखो क्या होता है ना, जैसे ऐसा देख लो, ऐसा कुछ सरफेस है। सबसे पहले साइन कन्वेंशन तुम कहीं भी लगा रहे हो ना, बी इट इन मिरर और लेंस, फर्स्ट यू नीड टू फिक्स द इंसिडेंट लाइट। तो हर बार ना मैं इंसिडेंट लाइट पहले फिक्स कर लेती हूँ। सो लेट्स से लाइट इज इंसिडेंट ऑन दिस सरफेस, एंड देन यू फिक्स द पोल ऑफ द, आई मीन पोल कहते हैं ना उसको, हाँ, पोल ऑफ द मिरर और ऑप्टिकल सेंटर ऑफ द लेंस, दैट विल एक्ट एज द ओरिजिन। सो ये है तुम्हारा ओरिजिन। अब ओरिजिन से ऐसे लाइन बनाते हो ना, एक्स एक्सिस, वाई एक्सिस। सो व्हाट इज द पॉजिटिव एक्स एक्सिस? सो पॉजिटिव एक्स एक्सिस इज द डायरेक्शन ऑफ, इन द डायरेक्शन ऑफ इंसिडेंट लाइट, सो दिस डायरेक्शन विल बिकम पॉजिटिव। ठीक है। अब सपोज करो इसके रेडियस ऑफ कर्वेचर R1 के लिए मैं साइन कन्वेंशन लगाना चाहती हूँ। सो यू विल सी हियर कि ये जो सरफेस है, ये जो सरफेस है, ये इसका सेंटर कहाँ है? तभी तो सेंटर से ही पोल का डिस्टेंस वही R1 होगा ना। सो इसका सेंटर कहीं इधर होगा। मेजरमेंट कहाँ से करते हो? ओरिजिन से करते हो। सो इफ यू विल मेजर R1, you will measure in this direction, R1. So in this direction you are measuring, that is in the direction of incident light. डन है। सो हियर R1 विल बी प्लस। डन है। सिमिलरली अगर यहाँ पे भी एक सरफेस होता है, ऐसा ऐसा कर्व सरफेस होता, तो इस कर्व सरफेस का तुम्हारा सेंटर किधर होगा? अगर इस कर्व सरफेस की बात करो तो इसका सेंटर विल बी समवेयर हियर। सो इफ यू हैव टू राइट द साइन कन्वेंशन फॉर R2, अगेन यू विल मेजर फ्रॉम द ओरिजिन। अब यहाँ के ओरिजिन में डिफरेंस हो गया, बट दिस डिफरेंस यूज्ड टू बी वेरी स्मॉल। ऑप्टिकल सेंटर थिन लेंसेज वी रीड, सो दिस इज वेरी स्मॉल। यहाँ से मेजर करो या यहाँ से मेजर करो, सेम थिंग्स है ऑलमोस्ट। सो in this direction you are measuring, that is in the direction opposite to the direction of incident light. So you will say R2 का साइन कन्वेंशन क्या होगा? नेगेटिव। डन है। सिमिलरली अगर तुम्हारे पास ऐसे ऐसे लेंसेस हैं, ऐसे लेंसेस है, अगर तुमने इस पे इंसिडेंट लाइट लिया ना, देन व्हाट विल हैपन? अगर इस सरफेस के लिए लिख रहे हो, इसका सेंटर ऑफ कर्वेचर इधर होगा, R2 you are measuring opposite to the direction of incident light, so here R2 will become negative, this वाला। ठीक है।
यस मैम।
ओके, चलो
यस मैम, थैंक
ठीक
यू
है।
मैम।
और कोई डाउट है तो बताओ।
नो मैम, नॉट राइट नाउ।
ठीक है, ठीक है, तो तुम सभी लोग क्वेश्चंस करो और ढेर सारा क्वेश्चन प्रैक्टिस करो, मिक्स करके करो, जैसे भी करो, बट कीप ऑन डूइंग मोर नंबर ऑफ क्वेश्चंस। ठीक है।
थैंक यू मैम।
Thank you so much. Varun, you have any doubt?
मैम, मैं जैसे
Yeah.
क्वेश्चन में इक्वेशनली करने की कोशिश करता हूँ, जैसे लाइक इक्वेशंस बना के। तो
हाँ
बट
हाँ
जब मैं ऐसे क्वेश्चन कर रहा था ना अभी कुछ दिन पहले रे ऑप्टिक्स का, तो उन्होंने ना
हाँ
रे डायग्राम से डायरेक्टली कर दिया।
हाँ हाँ।
मतलब कि ये फोकस पे बन रहा है तो डिस्टेंस वगैरह उन्होंने रे डायग्राम से ऐसे ही बना दिया। तो मैं ऐसे नहीं कर पाता, तो मुझे वैसे करके ट्राई करना चाहिए, क्योंकि मुझे लगता है उससे गलत हो जाते हैं। बट ज़्यादातर क्वेश्चन ऐसे कर देते हैं टीचर्स, और उससे लाइक जल्दी हो जाते हैं वो।
हाँ,
लाइक
रे
मैं
डायग्राम
क्वेश्चन
से।
भेजता हूँ, मैं जैसे एक क्वेश्चन भेजता हूँ वो बहुत कॉम्प्लिकेटेड हो रहा था उससे, जब मैं कर रहा था
हम्म। हाँ
एक
हाँ।
बेस्ट।
एक्चुअली देखो, टीचर्स बेसिकली कैलकुलेशन से इसलिए जाते हैं क्योंकि अगर तुम रे डायग्राम एक्यूरेटली नहीं कर पा रहे, आई मीन कहीं मिस्टेक हो सकता है। सो अगर थोड़ा भी मिस्टेक हुआ, यू विल बी गेटिंग इट रॉन्ग। अगर रे डायग्राम बहुत क्लियरली दिख रहा है, देन गो फॉर द रे डायग्राम, ऑब्वियसली दैट विल सेव योर टाइम। बट इफ इट इज नॉट दैट क्लियर, वी शुड गो विद a calculation. What you say?
मैम मैं तो इक्वेशनल से ही ट्राई करता हूँ, बट टीचर्स वो
अच्छा।
रे डायग्राम से कर देते हैं। उससे बहुत जल्दी हो जाता है, बट मैं क्लिक नहीं करता, उससे नहीं करता मैं, क्योंकि
हाँ
उससे
यार, वो नहीं
इनएक्यूरेसी
करना
ज़्यादा होती
चाहिए।
है।
देखो, टीचर्स, मी बीइंग अ टीचर, आई वुड से टीचर्स इसलिए कर देते हैं क्योंकि उनको पता है पहले से कि आंसर कुछ ऐसा है, उन्होंने पहले किया, उनको पता है वहां वहां ऐसे क्लिक करेगा, सो दे आर डूइंग इट। इट्स फाइन। लेकिन हमें कैलकुलेशन से जाना चाहिए एक्चुअली। अगर क्लियरली, बहुत जगह बहुत क्लियर होता है कि रे डायग्राम बहुत क्लियर है, तो बनाते हैं। अगर थोड़ा भी क्लियर नहीं है, डोंट गो फॉर द डायग्राम,
मैम
कैलकुलेशन ही
जैसे मैंने एक
सही है।
क्वेश्चन भेजा है देखो, इसके ना, और वैसे ना ये मैं उससे कर रहा था इक्वेशन से, मैं बहुत फंस गया इसमें, हुआ ही नहीं है।
अच्छा, इक्वेशन से नहीं हुआ?
ले एक क्वेश्चन है ये भेजा है, और मैम इसके ना
हाँ
आंसर बहुत सारे आ रहे थे। लेकिन जब सॉल्यूशन भी देखा तो बहुत सारे आंसर हैं। तो अगर ऐसा पेपर में होता है तो क्या करें? लाइक हमें पता
ठीक
चल
है।
गया
मैं,
कि इसके बहुत सारे आंसर हैं। तो
ओके, मैं इस क्वेश्चन को करके तुम्हें भेजती हूँ, ठीक है?
ओके मैम।
अ, हाँ, मैं इसको चेक करती हूँ। बहुत सारे आंसर्स क्यों आ रहे हैं, मतलब बहुत सारे आ रहे हैं?
मतलब मैम हाँ, बहुत सारे थे इसके सॉल्यूशन में। कैसे भी बनाओ हर से अलग आंसर आता है। लाइक पहले राइट साइड अगर वो इंसिडेंट कराऊंगा तो अलग आंसर आएगा, लेफ्ट साइड इंसिडेंट करवाऊंगा तो अलग आएगा।
हाँ, बट इन द क्वेश्चन इट शुड बी स्पेसिफिकली गिवन कि कौन से वाले से पूछ रहा है।
नहीं, आंसर के में भी बहुत सारे थे।
तो ये तो ऐसा क्वेश्चन तो हमें नहीं आएगा ना, क्योंकि हमें जब भी आएगा क्लियर
हमें
हो गया।
तो
नहीं तो फिर मल्टीपल होगा। मल्टीपल चॉइस अगर होता है तो फिर हम सारे से
न्यूमेरिकल
ऑब्वियसली।
था।
हाँ, तो
2023
न्यूमेरिकल।
का है मैम।
अच्छा। अच्छा, एग्जाम का क्वेश्चन है ये?
हाँ 2023 का पीवाई क्यूज ही करता हूँ मैं, वो नहीं करता।
अच्छा, तो इसमें तो कंफ्यूजन हो जाएगा ना, बच्चों को कैसे करेंगे वो?
इसमें अगर देखो, पहले राइट साइड इंसिडेंट कराते हैं तो आंसर अलग आता है। लेफ्ट साइड इंसिडेंट
हाँ,
कराएंगे पहले तो आंसर अलग आएगा। सब आंसर की
आएगा।
में था।
आंसर तो अलग अलग आएगा,
हाँ, और
डेफिनेटली
मैं
आएगा
इसे
क्योंकि।
बहुत इक्वेशनली कर रहा था, वो बहुत फंस गया, बहुत सारे डेटा आ रहा था, बहुत ज़्यादा वो कॉम्प्लिकेट हो रहा था। बट जब मैंने सॉल्यूशन देखा तो उन्होंने डायरेक्ट रे डायग्राम से कर दिया कि ये फोकस पे है तो इन्फिनिटी बनेगा, इन्फिनिटी से फोकस डिस्टेंस ऐसे सम करके कर दिया।
अच्छा, ऑब्जेक्ट फोकस पे रखा हुआ है।
हाँ कुछ कुछ ऐसा ही है।
ओके ओके। लेट मी चेक द क्वेश्चन सो दैट आई कैन टेल यू कि यहाँ पे मतलब मल्टीपल आंसर्स तो नहीं होने चाहिए। आंसर तो अगर इंटीजर टाइप है तो एक ही आंसर होगा ना।
वैसे देखा था मैंने, हो रहे थे। देखना आप
ओके।
इसे करके बता देना, इसे इसी के लिए आया था मैं
हाँ।
कि लाइक कुछ मैं शायद कुछ भूल रहा हूँ,
ओके ओके
तो
ओके।
मुझे लगा इसे
यू
कुछ
शुड हैव
मिल
सेंड
जाएंगे।
मी। आई विल सेंड यू। आई विल डू इट नाउ, ठीक है? आई विल
ओके
सेंड
मैम।
यू। ओके ओके। चलो ठीक है। ठीक है, थैंक यू, थैंक यू।